In the last lesson, we looked at exponent expressions that can be simplified because they involve the same base. Sometimes we don't have the same base, but instead we have the same exponent. Well, it turns out we have rules for those situations too, and that's what we'll be looking at today. Like last time, let's look at some examples which illustrate our two rules before we discover the rules themselves. So, if we have 2 to the power of 4 times 3 to the power of 4, we can write this in expanded form. Now remember, when we're multiplying, we can change the order of our factors without changing the value of the whole entire expression. So let's do that so that we pair each 2 with a 3. Well, if we do that, what we find is we're actually multiplying 6 4 times, or 6 to the power of 4. Now notice this only worked because we had the same exponent, because each base of 2 was able to pair up with a base of 3. If we had different exponents, that wouldn't have been possible. Suppose we have 12 to the power of 5 divided by 4 to the power of 5. We can write this in expanded form, which leaves us with a whole lot of multiplying within a fraction. Well, we can separate our fraction so that we're multiplying 12 divided by 4. Well, 12 divided by 4 is simply 3, so what we actually have is 3 to the power of 5. Notice again, this only worked because we had the same exponent. Each base of 12 was able to pair up with another base of 4. So these are the two rules that we're discovering for today. Rule 5, the base product rule, says that multiplying expressions with the same exponent is equivalent to multiplying the bases. And Rule 6, the base quotient rule, says that dividing expressions with the same exponent is equivalent to dividing the bases. As always, let's look at some examples to illustrate how these work. So 3 to the power of 7 times 5 to the power of 7, we have the same exponent, so we can multiply those bases to get 15 to the power of 7. 2 to the power of 4 times 9 to the power of 4, same exponent, means we can multiply the bases to get 18 to the power of 4. 63 to the power of 5 divided by 9 to the power of 5, the same exponent, means we can divide our bases, which gives us 7 to the power of 5. Now the following examples may look complicated, but if we take our time and apply the exponent rules that we've just learned today and the ones from our last lesson, we'll be able to see that these expressions are far less complicated than they appear. So firstly, we have an exponent of 3 over an expression being multiplied. We can actually apply Rule 5 in reverse here. We can apply that same exponent over both of our factors that are being multiplied. Now, we have 2 to the power of 5 to the power of 3. From Rule 3 from our last lesson, we see that that's 2 to the power of 15, multiplying our exponents. So now we can apply Rule 2 from the last lesson to get 2 to the power of 4 and 3 to the power of 1, which we can just write as 3. Now this expression is much simpler than what we started with, and something that we should be able to work out its value for. 2 to the power of 4 is 16, and if we multiply 16 by 3, we get 48. If we have 10 to the power of 2 times 10 to the power of 4, using Rule 1, that's 10 to the power of 6. Then if we have 5, which we can think of as 5 to the power of 1, divided by 5 to the power of 7, that's the same as 5 to the power of negative 6. But we know we can write that as dividing by 5 to the power of 6. Now because we're dividing expressions with the same exponent, we can divide the bases to get 2 to the power of 6, which is equal to 64. Let's look at some expressions we can simplify involving variables. If we have the exponent 2 over a product, we can apply that exponent to each base in the product separately. Then we have b to the power of 2 divided by b to the power of 5, which is b to the power of negative 3. So we have a to the power of 2 times b to the power of negative 3. If we have an exponent of 4 on the product 3x, we can apply that exponent separately. So 3 to the power of 4 times x to the power of 4. X to the power of 4 divided by x to the power of 5 is x to the power of negative 1. And 3 to the power of 4, we can write it as the number 81. So this is 81 times x to the power of negative 1.